At its core, Claude is a large language model designed to process and generate text based on the vast amount of information it was trained on. However, on its own, Claude is a closed system. It cannot see your private files, check the current weather, or execute complex math in a live environment. This is where skills, also known as tool use, come into play. Think of a skill as a bridge between Claude's internal reasoning and the external world. Instead of just guessing an answer based on past data, Claude can recognize when a request requires information or an action it cannot perform alone. It essentially pauses its thought process to ask for help from a specific software function. This transforms Claude from a static knowledge base into a dynamic assistant capable of interacting with digital tools in real time. For a skill to work, a developer must first provide Claude with a clear set of instructions called a tool definition. This definition is written in a structured format that acts like a detailed menu, telling Claude exactly what the tool does and what specific information it needs to function. For example, if the skill is a calculator, the definition specifies that it requires two numbers and a mathematical operator. It is crucial to understand that Claude does not actually see the code inside the tool. He only sees this high-level description. Because Claude understands natural language so well, he can map a user's casual request, such as what is the square root of 144, to the precise technical parameters defined in that tool's schema. This allows the model to translate human intent into a format that a computer program can execute. When you ask a question that triggers a skill, a specific three-step loop begins. First, Claude analyzes your prompt and determines that an external tool is necessary to provide an accurate or helpful answer. Instead of responding to you directly with a sentence, Claude outputs a special block of structured data called a tool use request. This request tells the underlying system which tool to run and provides the exact arguments needed, such as a city name for a weather check. The system then executes that code in its own environment and sends the result back to Claude. It is important to remember that Claude himself does not run the code. He acts as the orchestrator, deciding when to call for help and how to interpret the results he receives. Once the external tool returns the data, Claude enters the final phase of the process, synthesis. He takes the raw output, which might be a string of numbers, a list of files, or a status code, and integrates it naturally into a conversational response. This ensures the user receives a helpful, human-readable answer rather than a bunch of technical jargon. Throughout this entire process, safety and control are maintained through strict boundaries. Developers can implement human-in-the-loop checkpoints, where a person must manually approve a tool's action before it happens, especially for sensitive tasks like sending an email or moving a file. This combination of specialized skills and rigorous oversight allows Claude to be both incredibly powerful and reliably safe for complex professional tasks.